nothing up on the other ones.
No, just a couple years.
Exactly. Just wait up for Jen.
Are we all set?
Press the button.
Yeah, we good.
Oh, so I should just start?
Huh?
Okay. Hi, my name is Ben. I'm going to go over I'm gonna go over one of the L'Hopital problems. We've seen a lot of problems that do with L'Hopital's rule. I'm gonna go over a case that ends up tripping a lot of students up. So here's the example problem. When the limit as x approaches 0 of x minus sine x over x cubed. So, as I said, it's a L'Hopital problem. If you get it on the test, sometimes they'll tell you it's a L'Hopital problem. Otherwise, some good hints is that you have a fraction with polynomial and trigonometric functions in the top and the bottom. Anyway, so first thing, we have to check that we can use L'Hopital's rule. How do we do that?
Show that the numerator and the denominator are both 0?
Sure, exactly. Right. So let's do that. So x at x equals 0, you got 0 minus sine 0 is 0. On the bottom you have 0 cubed, so you have 0. So this is 0 over 0. It's an indeterminate form. We can use L'Hopital's rule. So this is equal to the new limit. Now again, we take the derivative of the top and the bottom. So what's the derivative of the top? Derivative of x, just shout it out, 1. Derivative of sine. All right, what's the derivative of the bottom? 3x squared, good. Okay. So what do we do now? Well, we can try and plug it in. We get 1 minus cosine 1 is 0. 1 minus cosine 0 is 1 minus 1 is 0. We get 3 times 0 at the bottom, so we have 0 over 0 again. A lot of people stop here and say, oh, well, now I don't know what to do. Whenever you have a 0 over 0, you can keep on using L'Hopital's rule. So what we're going to do is we're going to say, so this is an indeterminate form. We're going to keep going. We're going to apply L'Hopital's rule again. So what do we get next? First of all, so derivative of 1 is 0, that's right. So I'll just write it 0 minus, so what's the derivative of cosine?
Minus sine.
Right, so minus is plus, so plus sine x over, what? 6x, good, okay. So this is the limit of sine x over 6x. So let's try and plug that in. What do we get? 0 over 0. Okay. Again, don't panic. Just apply the L'Hopital rule again. What do you get? Right. Cosine x over 6. Okay. So now, just have to plug it in. Yeah, 1 over 6 is exactly what you get. So yeah, moral of the story, don't panic, just keep going. I thought that would take longer. But yeah, any questions? Sure.
What happens if there's a function with infinitely many derivatives on the bottom as well?
Ah, well, so that's something you have to check. That's a good point. I can talk about that a little bit. So what we want to make sure is that we have a pattern going on that eventually ends. Here we see that the bottom kind of goes x cubed, x squared, x to 6, and that is going to end eventually. If you had something like 1 over x in the bottom, you might want to so what it usually comes down to is rearranging the limit to make it something that you can work with. So you might see something like with 1 over x in the bottom, you could just throw it in the top. So like 1 over x is x. Yeah. Okay, any other questions? Sure.
What if you have cosine x over e to the x?
Cosine x over e to the x. I guess, well, actually, you know what? That's easy L'Hopital problem. So, limit as x approaches 0, or maybe not, of cosine x over e to the x. First off, check by plugging it in. What's the cosine of 0? 1. E to the 0 is 1. So, the limit is 1. Yeah. Or I guess, did you mean something else though? Or, I don't know. Okay. I guess you could have this, that would be a little bit, well, no. All right, so if there are no more questions, I guess that's it. No, thank you.
Should we record it?
Yeah. So we covered.